Hello students and good afternoon. So now I am doing class for class 12. So today's topic is the function. So in the last online class also we did function. So in that online class we did what is a function and we did different types of functions and I told you about what is a function, different types of functions, that is one function, that is your injective function, onto function, that is your surjective function, many one function, and into function. So I think you revised all these definitions and I had shown you some examples also. So now today we will do problems on these different types of functions. Okay, so question number 1, let f such that n to n. Here n is natural number. It is not mentioned what is n out here. Actually n is natural numbers. It is read as f such that n to n. This first n is known as the domain and this second n is known as codomain. You should know it. It can be read as f maps n to n also. F maps n to n. Let the function f such that n to n, or it can be read as let the function f maps n to n. This first n is known as domain, I told you that, and this second n is known as codomain, and this function f is defined as f of x is equal to 2x for all. You know the meaning of this symbol. For all small x belongs to the set of natural numbers. Is that clear? So you have to show that f is 1 and into function. First of all, you have to show that this function f is 1 function. So you know how to show f as 1 function. Okay. So in order to show f as 1 function, you should write f of x1 is equal to f of x2, and then you have to prove x1 is equal to x2. So if you can prove x1 is equal to x2, then f is 1 function. Is that clear? So let us prove it now. So this is the solution. So here given is f of x is equal to 2x for all x belongs to the set of natural numbers n. Okay, so now we know that f of x1 is equal to f of x2. Okay, which implies that f of x1, so instead of x, if you put x1 here, what is the value for f of x1? 2x1. So this is your 2x1 is equal to, what is f of x2? F of x2 is equal to 2x2. So this is your 2x2, right? Here 2 gets cancels. So which implies that x1 is equal to x2. That means what can we say about the function f? F is 1 function. So hence f is 1 function. So in this case we have proved that f, the function f is 1 function. Okay. Now let us prove into function. So what is meant by into function? The into function को definition चाहिँ के थियो त? त यो जुन चाहिँ if the function f such that a to b is there, so there are some elements in the set b which do not have pre-image in the set a. That is known as into function, isn't it? So now the into function को definition सायद सबैलाई थाहा छँदैछ हैन? A function f such that a to b is said to be an into function if there exists at least one element in the set b which do not have any pre-image in the set a. That is known as into function, right? So now, so let us prove f as into function. Okay. So now let us assume, let this 2x be y. So let y is equal to 2x. So here this y belongs to the codomain n, right? So or what is the value for x? Let us get the value for x. X is equal to y upon 2. Is that clear now? So now in this case y upon 2 is there. So here this y belongs to the codomain n. So therefore here y belongs to codomain n. Suppose if you put y is equal to 3. So you know that 3 belongs to y. 3 belongs to y. If you put y is equal to 3 here, what is the value for x? Suppose if you write like this, if y is equal to 3, then x is equal to 3 by 2, isn't it? This y belongs to the codomain n and this x belongs to the domain n. So here x belongs to domain n. X belongs to the domain n, right? But this 3 by 2 does not belong to the natural n, isn't it? But 3 by 2 does not belong. But 3 by 2 does not belong to the domain n. Domain n, because this domain n is also a natural number. So this 3 has no pre-image. This 3 has no pre-image in the domain n. So therefore 3 belongs to y doesn't have. So therefore 3 belongs to y, that is 3 belongs to y. 3 is a natural number. 3 belongs to y is a natural number, doesn't have any pre-image, does not have any pre-image in domain n. तो यो जुन चाहिँ नम्बर 3 y मा पर्दैछ, यो जुन चाहिँ नम्बर 3 y मा पर्दैछ, यो 3 को कुनै प्रकारको प्री इमेज चाहिँ डोमेन n मा छैन। भनेपछि यो कसैले फंक्सन हो? This function is known as into function. So therefore the function f is an into function. Is an into function. किनभने यो जुन चाहिँ 3 belongs to the codomain n, because these 3 belongs to the codomain n, this 3 does not have any pre-image in the domain n. So that's why the function f is an into function. So hence the function f is 1 1 and into function. So it is proved. So I think you have understood it. So you can copy it. So now we'll do the next question. So now we'll do the next question, that is question number 2. So I forgot to tell you one thing, that is for these questions I'm using this book from R.S. Agarwal, that is Senior Secondary School Mathematics for Class 12 by R.S. Agarwal. हामीले चाहिँ यो किताबबाट गर्दैछौँ। यो किताब चाहिँ कसले लेखेको भन्दा श्री R.S. अग्रवालले लेखेको किताब हो। यो किताबबाट चाहिँ म तिमीलाई प्रब्लमहरु गराउँदै छु। ठीक छ? So let's do this problem number 2. So that the function f such that r to r means here real number, right? This first r is known as the domain and this second r is known as the codomain. R means the set of real numbers such that this function is defined as f of x is equal to x square. E is neither 1 1 nor onto. यो 1 1 function पनि होइन, onto function पनि होइन भनेर हामीले देखाउनु पर्छ। So I think you have understood it. You have understood the question, right? So now let's do this problem now. So now here given is f such that R to R and function is defined as f of x is equal to x square. So it is not 1 1. You 1 1 function haina bhanera हामीले prove गर्नुपर्छ. So how will you prove it that it is not 1 1 function? So here x, this x belongs to the domain R, and this x square or f of x belongs to the codomain R. Both are real numbers, right? So now in this case, if you put f of minus 1, which is equal to minus 1 whole square, we are using this function. If you put x is equal to minus 1 here, this is minus 1 whole square, which is equal to 1, isn't it? Right? Again, if you put 1, f of 1 is equal to, this is 1 whole square, which is equal to 1. So in this case, that is f of minus 1 is equal to 1, f of 1 is equal to 1. These are equal. So which implies that f of minus 1 is equal to f of 1 because both are 1. But minus 1 not equal to 1. You know that, isn't it? But here minus 1 not equal to 1. That means it is not 1 1 function. For 1 1 function, it should be such that if f of x1 is equal to f of x2, then it should imply x1 is equal to x2. But in this case, minus 1 not equal to 1. So the function f of f, so the function f is not 1 1. It is not 1 1 function. This is many 1 function, right? So now we have to prove that it is not onto function. It is not onto function. That means there are some elements in the codomain R which don't have any pre-image in the domain R. Is that clear? So you know that minus 1. You know that minus 1 belongs to the codomain R, isn't it? Codomain R. You know that minus 1 belongs to codomain R. But this minus 1, here we see that this minus 1 does not have any pre-image in the domain R, isn't it? So here we see that minus 1 does not have any pre-image, Here we see that this minus 1 does not have any pre-image in the domain R. त तिमीले यहाँ x is equal to 1 हाल्दा minus 1 हाले पनि 1 नै हुन्छ, त x is equal to 1 हाल्दा पनि 1 नै हुन्छ. तर यो f of x मा minus 1 हुन सक्छ because this is the set of real numbers. त यो minus 1 चाहिँ यो कोडोमेन R रियल नम्बर्स मा हुन सक्छ. तर यो minus 1 को प्री इमेज चाहिँ यो डोमेन R मा हुँदैन. बुझ्नुभएन? That means this minus 1 does not have any pre-image in the domain R. That means minus 1 is not related to this domain R. So that means it is an into function. So it is not onto function. So hence the function f is not an onto function. So I think you have understood it. So hence the function f is neither 1 1 nor onto. nor onto. So we have proved it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 3. So that the function f maps real to real number, this first R is known as the domain and the second R is known as the codomain, which is defined as f of x is equal within mod x. This is known as modulus function. Okay, you know about modulus function. I told you about modulus function in continuity and differentiability, isn't it? So I told you about the greatest integer function also in differentiability and continuity. So this function, this f of x is equal within mod x is neither 1 1 nor onto function. So यो function पनि 1 1 function पनि होइन, onto function पनि होइन भनेर हामीले प्रुभ गरेर देखाउनु पर्छ. तो यहाँ given के छ? What is given now? Let's do the solution. If such that R to R and this function x is function of x is defined as within mod x. So if you write, so you have to prove that this is not 1 1 function. So if you write f of 1 is equal to, so here we are putting x is equal to 1. So within mod 1 means 1, isn't it? So therefore f of minus 1 is also within mod minus 1, which means 1. So in this case we see that f of 1 is equal to f of minus 1, but here 1 not equal to minus 1. So this is not 1 1 function. यो 1 1 function हैन. किनभने यो जुन चाहिँ 1 र minus 1 छ, यो 1 र minus 1 को इमेज चाहिँ 1 मात्रै छ यहाँ. सेम इमेज आयो के हैन? तो यो 1 र minus 1 को सेम इमेज 1 आउँदैछ भने this is many 1 function. So this is not 1 1 function. Okay, also we have proved that if f of 1 is equal to f of minus 1, this 1 1 equal, that means this left hand side must be equal. So f of 1 is equal to f of minus 1. So in this case, but 1 not equal to minus 1. So hence the function f is not 1 1. So is that clear? So now we have to show that, so we have proved here the function f is not 1 1. Now in the second part you have to prove that f is not onto function. That means there are some elements in the codomain R which do not have pre-image. There are some elements in the codomain R which do not have any pre-image in the domain R. यहाँ R जुन चाहिँ कोडोमेन रियल नम्बर छ, यो सेकेन्ड R जुन चाहिँ छ यसलाई हामी कोडोमेन भनेर भन्छौं. यो कोडोमेन R मा त्यहाँ एटलिस्ट कुनै एउटा एलिमेन्टहरु छ जसको प्री इमेज चाहिँ डोमेन R मा छैन भनेर हामीले देखाउनु पर्यो, हैन? So you know that in this real number minus 1 belongs to codomain R. Codomain R. Okay, minus 1 belongs to codomain R, but in the domain R there are no elements here whose image is minus 1, right? So this minus 1 which belongs to codomain R does not have any pre-image, in domain R means this first R, in domain R. तो यो जुन चाहिँ -1 को डोमेन R मा पर्छ, रियल नम्बरमा -1 हुन्छै हुन्छ, त त्यसको इमेज चाहिँ यो डोमेन R मा छैन. बुझ्नुहुन्छ नि? किनभने हामीले यहाँ 1 हाले पनि 1 नै हुन्छ, -1 हाले 1 नै हुन्छ. त यहाँ -1 हाल्यो भने -1 आउँदैन, यहाँ -1 हाल्यो भने के आउँछ 1 नै आउँछ। भनेपछि यो -1 जुन चाहिँ कोडोमेन R मा छ त्यसको इमेज चाहिँ हामी यो डोमेन R मा पाउँदैनौँ। So that's why it is not an onto function. So therefore the function f is not onto function. Therefore the function f is not onto function. Is that clear? So I think you have understood it. So hence the function f, hence the function f is neither 1 1 nor onto. So we have proved this result. So you can copy it. Now we'll do the next problem. So now we'll do the next problem, that is problem number 4. For any real number x we defined within square bracket or within third bracket there is x. Its meaning is greatest integer function less than or equal to x. Your greatest integer function which is less than or equal to x, we have done it in continuity and differentiability. I told you the meaning of this expression also, that is within third bracket or within square bracket there is x. What is its meaning? Greatest integer less than or equal to x. So let us revise it once again. So if you write within third bracket 1.999, this indicates that this is the greatest integer function which is less than 1.999. Which is the greatest integer less than 1.999? Can you write 2? No, 2 is more than 1.999, but 1 is less than 1.999. So this is the 1 is the greatest integer which is less than 1.999. Okay, if you have 1, you may write 1. 1 is equal to 1, you may write it. 1.999 is greater than 1, but this 1 is less than 1.999. That means 1.999 भनेपछि के रहेछ? Greatest integer less than 1.999. That is within third bracket 1.999 means greatest integer which is less than 1.999. So which is the greatest integer which is less than 1.999? That is your 1. If you write within third bracket 1, you will have 1, right? So if you have minus 1.999, so what is it? Which is the greatest integer? Negative integer. You can take negative integer also, isn't it? But this is not your integer, this is your decimal fraction. So which is the greatest integer which is less than minus 1.9999? It will be minus 2. This will be minus 2. Is that clear? So if you have minus 1, you can write minus 1. If you have minus 1.2, so which is the greatest integer which is less than minus 1.2? It is minus 1. I think you have understood it. So what is meant by 3.2, which is 3, isn't it? So which is the greatest integer less than 3.2? That is your 3. And 3 is also 3. Within third bracket 3 is also 3. So I think you have understood this meaning. Okay. So this is just an example. Now let's do this problem now. So here you have to prove that this greatest integer function f such that real to real number, it is defined as f of x is equal to within third bracket x, which is the greatest integer function, is neither 1 1 nor onto. You have to prove it. So solution is, here what is given here, f such that r to r is defined as f of x is equal to, within third bracket, it is x. You have to prove that it is neither 1 1 nor onto. First, you prove that this function is not 1 1 function. Okay? So if you put, suppose, if you put 1.999, you will have 1. Isn't it? By definition. That is within third bracket. If you write 1.999, it means that greatest integer which is less than 1.999. That is your 1. Okay? You may have 1 is equal to 1. Okay? You may have 1.2 is equal to 1. So all these values which belongs to this domain R, they have got the same image 1 in the codomain R. Is that clear? This 1.999, 1.2 is equal to 1. That means here also you can write. So if you write f within bracket x, what is x here? 1.999, which is equal to, within third bracket, 1.999. It means by definition the greatest integer which is less than 1.999. What is it? This is 1. Again, f of 1 is equal to, this is within third bracket. You can put x is equal to 1 here. Within third bracket, this is 1, which is also 1, right? If you write f of 1.2, f of within bracket 1.2, it means that within third bracket 1.2, which is also 1. So this indicates that this 1.999, this 1 and 1.2 belongs to the domain R. All these values of x have got the same image 1 1 1 in the codomain R. That means it is many one function, isn't it? So since here f of 1.999, so you can take these two example. F within bracket 1.999 is equal to f of 1, but 1.999 is not equal to 1. So this is the example of many one function, isn't it? So here you can write, that therefore the function f is not 1 1. The function f is not 1 1. ठीक छ? त तिमीले जतिसुकै x को भ्यालु हाल, त तिमीले त्यसको इमेज सबै के पाउँछ, हामी इन्टिजर मात्रै पाउँछौं. ठीक छ? तर यो कोडोमेन R मा त अरु इन्टिजर्सहरु पनि अरु नम्बर्सहरु छ. दैट इज decimal numbers are also there in R, isn't it? That is so therefore now we will prove that this is not onto function. Okay, so you know that 1.99, this 1.99 belongs to codomain R, isn't it? Codomain R, codomain R, right? So यो जुन चाहिँ कोडोमेन R छ, सेकेन्ड R छ, त्यो कोडोमेन R हो. त्यो कोडोमेन R भनेको रियल नम्बर त 1.99 पनि हो. This 1.99 belongs to the codomain R. तर यो 1.99 जुन चाहिँ कोडोमेन R मा पर्दैछ, त्यसको इमेज यो डोमेन R मा हुन्छ? डोमेन R मा हुँदैन, किनभने यो डोमेन R मा हामीले 1.99 लेख्ने बित्तिकै यो फंक्सनले के बनाइदिन्छ? इन्टिजर बनाइदिहाल्छ, 1 बनाइदिहाल्छ. भनेपछि यो 1.99 जुन चाहिँ कोडोमेन R मा छ, यसको कुनै प्रकारको प्री इमेज यो डोमेन R मा हुँदैन. बुझ्यो? दैट मीन्स इट इज नट onto function. बुझ्यो? त onto function मा चाहिँ के हुन्छ भन्दाखेरि, onto function मा चाहिँ जति पनि एलिमेन्ट्स जति पनि एलिमेन्ट्सहरु हुन्छ यो कोडोमेन R मा त्यसको एटलिस्ट वान प्री इमेज यो डोमेन R मा हुनै पर्छ भएन भने के हुन्छ त्यो इन्टु फंक्सन भइहाल्छ इज दैट क्लियर टु अल अफ यु सो यु क्यान सी द डेफिनेसन अफ onto function and into function then it will be clear for you to understand it okay त तिमीलाई मैले अघि नै भने डेफिनेसन राम्रोसँग तिमीले पढेको हुनु पर्यो बुझेको हुनु पर्छ ठीक छ डेफिनेसन बुझ्यो प्रब्लम गर्न सकिहाल्छ if you know the theory portion then you can easily do the problems the theory portion पनि जान्नु पर्यो प्रब्लम्स पनि जान्नु पर्यो ठीक छ so you know that 1.99 belongs to codomain R but 1.99 does not have any pre-image in the domain R so but यो जुन चाहिँ 1.99 छ codomain R मा it does not have any pre-image in the domain R so therefore the function f is not onto therefore the function f is not onto is that clear so now we can write down the answer here as hence the function f is neither 1 nor onto so we have proved it okay so you can copy it now we'll do the next question so now we'll do the next question that is question number 5 the question number 5 is let capital R naught or capital R0 this 0 is the suffix it may be read as let capital R naught be the set of all non-zero real numbers non-zero real numbers means त त्यहाँ यो सेट रियल नम्बरमा 0 इन्क्लुड हुँदैन 0 is excluded out here okay so that if such that R0 to R0 this first R0 is known as the domain this second R0 is known as the codomain and the function is defined as f of x is equal to 1 upon x is 1 1 onto function so 1 1 onto function means that is also a bijective function you have to prove that this function f is a bijective function so let us prove it so solution so here given is f such that R naught to R naught or R0 0 is the suffix here and it is defined as f of x is equal to 1 upon x okay so in order to prove onto function in order to prove 1 1 function you have to prove that if f of x1 is equal to f of x2 it implies that x1 is equal to x2 okay so we have f of x1 is equal to f of x2 for x1 x2 belongs to R naught this x1 comma x2 belongs to R naught isn't it this x1 comma x2 belongs to R naught right so which implies that x1 if you put instead of x1 what is the value for f of x1 it is 1 upon x1 which is equal to now instead of x if you put x2 what is the value for f of x2 that is here 1 upon x2 which implies that you can do cross multiplication here so x1 is equal to x2 so here x not equal to 0 so it is a defined quantity because x is not equal to 0 out here okay so here x not equal to 0 तर यदि यो 0 भयो के हुन्छ अनडिफाइन्ड त्यही कारण अनडिफाइन्ड नहोस् भनेर यो पहिला नै हामीलाई के दियो all non zero real numbers non zero means 0 is excluded in this problem, right? So what can you write here? Therefore it indicates that the function f is 1 1. The function f is 1 1 function. Therefore the function f is 1 1 function. Okay, so now let us prove this function as onto function. Okay, so for onto function, the method is you have to assume y is equal to 1 upon x. So let y is equal to 1 upon x. Here x is non-zero quantity, right? Or x is equal to 1 upon y. So here x is equal to 1 upon y. Okay, so here also y belongs to what? Y belongs to R0, R0. This y belongs to this codomain R0 or R0. So here also this y is not equal to 0 because it is given that so R0 is the set of all non-zero real numbers. In this case also 0 is also excluded. Okay, now for every y belongs to R0, comma, there exists, this is the symbol of there exists x is equal to 1 upon y belongs to R0. X is equal to 1 upon y belongs to R0 such that f of x is equal to f of. So for onto function you have to prove that for every y belongs to the set, for every y belongs to the set of real numbers, there exists x belongs to the set of real numbers such that f of x is equal to y. You have to prove that f of x is equal to y. This is from the definition, isn't it? So f of x is equal to f of, what is the value for x here? 1 upon y. It is 1 upon y. Now let us get the value for f of 1 by y. If we put here instead of x 1 by y, it will be 1 upon 1 by y, which is equal to y. So now each y belongs to R0 has a pre-image in R0, that is your domain, right? So let us write here. So therefore for each y belongs to R0, for each y belongs to R0 has its pre-image, in domain R0, okay? So this indicates that for each y belongs to R0 has its pre-image in the domain R0. Is that clear? So hence the function f is onto function. So we can write hence the given function f, is 1 1 onto function. So it has got a special name. If the function is 1 1 onto function, then this function is also known as bijective function. यसलाई हामी के function पनि भन्छौं? Bijective function. So it is proved. So I think you have understood it. So you can copy it. So now let's do the next question, that is question number 6. You have to prove that the function f such that real to real number, and this function is defined as f of x is equal to x cube, is 1 1 and onto. You have to prove that this function is 1 1 and onto function, that is of bijective function. Okay, so let us prove it now. The solution is here it is given a function f such that real to real number and is defined as f of x is equal to x cube. So you know the mathematical proof of proving one function. So if you have f of x1 is equal to f of x2, that is x1 x2 belongs to the real number, then you have to prove that if f of x1 is equal to f of x2, then x1 is equal to x2. Okay, so now let us write here, we have f of x1 is equal to f of x2. Both these x1 comma x2 belongs to the domain R, right? Which implies that, so in this case, instead of x, if you write x1, so what is the value for f of x1? x1 cube. This is x1 cube is equal to, what is f of x2? Instead of x, you put x2, so this is x2 cube, right? So if the powers are equal, bases must be equal, which implies that x1 is equal to x2. So I think you have understood it. So therefore the function f is 1 1. So therefore the function f is 1 1. Okay, so now let us prove onto function. So what is the method of proving onto function? Now you have to assume y is equal to x cube. So for every y belongs to the codomain R, there exists x belongs to the relation, or there exists x belongs to the domain R. So what I mean to say here is, you have to assume y is equal to x cube now. So now for every y belongs to the set or belongs to the codomain R, there exists x belongs to the domain R such that f of x is equal to y. Okay, so now let us prove it. So let us assume y is equal to x cube. Now get the value for x. What is the value for x here? It is just like cross multiplication in the power. So what is the value for x only? It is y to the power 1/3, right? Now here you have to write for every y, for every y belongs to codomain R, that is, if y is real quantity, then whole to the power 1/3, x is also a real quantity. You know that, isn't it? If y is a real number, then a real number whole to the power 1/3 is also a real number. That is, you will get x as real number. Okay, so for every y belongs to codomain R, comma, there exists x is equal to y to the power 1/3 belongs to domain R such that f of x is equal to f of what is the value for x here? It is y to the power 1/3. It is y to the power 1/3 is equal to, so now in this case, if we put y to the power 1/3 here, what is f of y to the power 1/3? It is actually f of x is equal to x cube. So if we put instead of x is equal to y to the power 1/3, what is the value of this function of y to the power 1/3? So it will be y to the power 1/3 whole cube, isn't it? That is, instead of x, if you put y to the power 1/3, it will be y to the power 1/3 whole cube, isn't it? Because we are putting x is equal to y to the power 1/3. So instead of x, if you put y to the power 1/3, it will be y to the power 1/3 whole cube. This 3 will be cancelled, isn't it? So I think you have understood it. So which is equal to, this is your y. Okay, so for every small y belongs to codomain R, there exists x is equal to y to the power 1/3 that belongs to domain R such that this f of x is equal to, we have proved, which is equal to y. So hence what can you write? The function is onto function. So therefore the function is onto. So hence the function f is 1 1 and onto function. So we have proved it. So I think you have understood it. You can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 7. The question number 7 is, so that the function f maps or such that r to r, here r is real numbers, and the function is defined as f of x is equal to 3 minus 4x, is 1 1 onto and hence bisective. So if the function is 1 1 onto function, then it is automatically bisective function. Okay, so 1 1 onto function लाई हामी के function पनि भन्छौं, bisective function भनेर पनि भन्छौं. त पहिला हामी के प्रुभ गर्छौं, 1 1 onto function. त 1 1 onto function प्रुभ गर्नलाई हामी के लिन्छौं, x1 x2 belongs to the domain and we have f of x1 is equal to f of x2 is should imply that x1 is equal to x2. So if we can prove it, then we can write down that the given function is 1 1 function. Okay, so let us prove it now. So the solution is, here given is f such that r to r and the function is defined as f of x is equal to 3 minus 4x, right? So we have f of x1 is equal to f of x2 for all x1 x2 belongs to the domain R. This R means domain R, right? So which implies that if f of x is equal to 3 minus 4x, so instead of x you have to prove you have to put x1, isn't it? So what do we get? It is 3 minus 4x1 is equal to, now instead of x you put x2, so this will be 3 minus 4x2. So I think you have understood it. So here 3 gets cancels, which implies that minus 4x1 is equal to minus 4x2. Here also minus gets cancels, 4 gets cancels, which implies that x1 is equal to x2. So we have proved that if f of x1 is equal to f of x2, then x1 is equal to x2. That means the function f is 1 1 function. Therefore the function f is 1 1. Now what is to be proved? We have to prove that f is onto function now. अब हामी यो function f चाहिँ onto function भनेर प्रुभ गर्छौं. त्यसको लागि के हुन्छ मेथड, यो जुन चाहिँ f of x is equal to 3 minus 4x दिएको छ त्यसलाई हामी y सपोज गर्छौं. ठीक छ? The rule is you have to assume 3 minus 4x as y. So let y is equal to 3 minus 4x. Now let us get the value for x in terms of y. अब हामीले के गर्नुपर्छ, y सपोज गरेपछि x लाई हामी in terms of y निकाल्छौं. So or this is 4x is equal to 3 minus y, or what is the value for x here? It is 3 minus y upon 4. Is that clear? Now let us write here for every. So now in this case, this y is real number. This y belongs to the codomain R. Y is a real number. If y is a real number, then x is also a real number, isn't it? That is, if y belongs to this codomain R, then x belongs to the domain R such that f of x is equal to y. You have to prove it for onto function, isn't it? For every y belongs to codomain R, there exists this x belongs to domain R This domain R means this first domain R such that f of x is equal to f of, instead of x, what should we put? 3 minus y upon 4. Is that clear? Which is equal to, now, so how can we get the value for f of 3 minus y by 4? So here, instead of x, f of x is equal to 3 minus 4x. So instead of x, you have to prove 3 minus y upon 4 here. So it will be 3 minus 4 into, what is x here? Here x is 3 minus y upon 4. Is that clear? So here you can cancel this, 4 gets cancels, which is equal to 3 minus 3 minus minus plus y. Here 3 gets cancels, which is equal to y. Is that clear now? So now every element y that belongs to the codomain R has its pre-image in the domain of R. Is that clear? So here you can write, hence for every y belonging to the codomain R has its pre-image, hence for every y belonging to the codomain R has its pre-image in the domain R. In the domain R. So therefore the function f is onto function. So here we have proved that the function f is, therefore the function f is 1 onto function. So we have proved that the function f is 1 onto function. That means 1 onto function means it is a bijective function. So hence the function, because in this case you have to prove hence bijective function. So if you have proved that the function is 1 onto function, then it is automatically bijective function. Hence the function f is a bijective function. Hence the function f is a bijective function. So we have proved it. So I think you have understood it. So I think you have understood all the problems that we did today. त आज हामीले जति पनि प्रब्लम्सहरु गर्यौं यो सबै तिमीले घरमा राम्रोसँग रिभिजन गर्नु। त नेक्स्ट क्लासमा म अझै यो भन्दा अझै अलिक अप्ठ्यारो प्रब्लमहरु देखाउने छु। त त्यसको लागि यो प्रब्लमहरु तिमीले राम्रोसँग गर्ने छौ। ठीक छ? So this much is for today.